All right, let's try this one, this race condition project. So first you have to make a new account. You can be any account you want to start out with. I'm using a Debian machine on ARM, and so it doesn't really matter whether it's ARM or Intel. I'm logged in as a user Debian with sudo privileges, so I do sudo add user. And I already did this project on this machine, so I'm going to make a new account for this demo called Noob2. So I give it now first I have to give it my Debian password for my privilege elevation with sudo. And now I have to give it the password for the Noob2 account, which is going to be Noob2. And now it's going to ask me for their name and stuff, and I'm just going to use the default values of nothing for all that. And now I have a user called Noob2. And the point is this user is not an administrative user or a sudo user. They're a low privilege user. All right, so what we're going to do is make this vulnerable program, which I have already made. Let's see if I've got it here. Looks like I don't have it in this directory. I'll just chapter. Oh, that's why I put it in a different directory. Let me go here at cd ed202, ed210. There we go. All right, here's the program. So I cat race.c, and we'll see how this works. Okay, so you include a whole bunch of libraries, and your main function is going to, you've got time among other things. And so what it's going to do is print a file if you have access to it. So here is, it measures the time at which you do this operation and stores it in T0, and it's going to check to see if you have read access to the file in the command line parameter 1. So you run this on a file. Here it checks to see if you have read access. Now here it wastes some time. And then here's where it records the time of use. It opens the file and prints the output, or it gives you an error message if it can't open the file. And the point is, this is not an atomic operation. You have measured your permissions here, and you have read the file here, and there was some time between those. So it is possible that another thread would have changed something in between those two times, and that's what we're going to exploit, and that is a race condition. A race condition is when there is a time of check and a time of use, and something happens in between those times. And that's what we created here. And I deliberately arranged something here just to waste that time to make the vulnerable period longer, so it's easy to make a good demonstration of this instead of having to, realistic ones you might have to try millions of times to get lucky. This one here is going to be so vulnerable, something like 10% of the time you'll be able to exploit it. All right, so that's what that code is. Control C. All right, so now we're going to copy it to temp. And let me just make this here. They'll probably, okay, so we're going to copy that code up to temp because right now it's in my current user's home directory or something, and I want it to be in a place where every user account has easy access to it. And then I'm going to elevate to root with sudo su minus. Now I'm root, you can tell by the # prompt. And now I can compile it here. So I'm going to run it and make race. And now I'm going to do ls-l. So I've created a file called race, which is executable, and it's just got read, write, execute, and read execute permissions. But I want to set the suid bit, which is this one here, and you do that with chmod 4755. That sets that unusual highest order bit. So if you do ls-l, you'll see RWS. Oh, sorry, I shouldn't have. This is actually the indicator of whether it's a file or directory. It's the S here that indicates a suid file. And that means this program can be run by anyone because I have execute, 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 but it always runs as root. And this is what leads to privilege escalation vulnerabilities. It's considered an unwise practice, but it is the standard way a whole lot of things have worked in Linux, is you temporarily elevate to root while doing something like changing your password. So we now made it a suid file, and now we're going to put this suid file in the home directory of the low privilege account that we just created, which is noob2. Oops, I need the sudo. All right. And now I can exit, which is going to mean I stop acting as root. And now I'm going to make a secret file. So let's, while I'm logged in as my regular user, I can do this. I'm going to create a file called secret in the noob directory. And in there I'm going to put secret information. And save that file. All right, and now I'm going to change it to 600 permission, which we'll see if I do ls-l of home noob2 secret. I can't even, okay, I can't read the permissions from this account from where I am, but I can, oh, if I do sudo, I can. There. So now I can see right now this secret file is readable by everyone. So I don't want that, so I'm going to do this chmod 600 of noob2 secret. And now if I do this, I'll see now it can only be read by root, not by anybody else. So the noob person is not going to be able to do it. So now I'm going to change to them. So let's clear and su noob, switch user to noob, noob2, and my password is noob2. Okay. And now I can do cd to go home, and then you see now my printing work. I'm now in home noob2, and if I do an ls-l, there's a secret file here I'm not allowed to read, and there's a race program here that I can run that has the suid bit set. So I can cat secret, and it won't let me in. All right, so now I'll make a public file and put in public information. All right. And that one I can read, of course. I'm cat public. Okay, I'm allowed to read that one, but I'm not allowed to read the secret one. Okay, now I'm going to use the race program. Now the race program might run as root, but remember, it checks to see who I am and whether I have permissions to access that file. So even if I use the race program and try to read secret, it's going to tell me I'm not allowed to. I can read public. So this program is not like trivial. It's not just letting everybody have root permissions. This program is still only letting me access files if I have permission. The problem is it has a race condition vulnerability. And the way you exploit it is with a symbolic link. So this will create a symbolic link to public named flip. And if I do ls-l, I will now see this object called flip, which is just what Windows calls a shortcut. It's just a pointer that links back to this file named public. So I can do race, let's do race public, or I can do race flip. And that'll be the same thing. Flip is just a pointer that goes to public, so I see the public. All right, so now I'm going to overwrite the symbolic link. If I try to change the link to go to secret, it's going to complain because you can't just change the link on top of the existing link, but you can if you use the F flag. If I use F, that forces it to override the existing link. And now if I do my ls-l, I'll see flip now points to secret. And now if I run race on flip, I'm not allowed in because I have not got the permissions. So I've not had anything unusual happen yet. All the permission structure is working as intended. Now, we want to make a loop to flip things back and forth. So here's something that's going to change the flip, make the flip go to secret, and then make the flip go to public. And I'm going to do that 1,000 times and see how long it takes. I'm just going to count the seconds. So it's 1, 2, okay, it only took about 1 second to flip it 1,000 times. So I can flip it in about a millisecond. And notice the vulnerable time interval seems to be about 10 milliseconds here. Around 10,000 microseconds seems to be the vulnerable time in my program. So if I flip every millisecond, I have a pretty good chance of doing a flip in that vulnerable time period. So I can do constant flipping with a while loop. This will just flip back and forth at whatever the fastest rate the bash command interpreter can do it, which appears to be every millisecond or so. So now that thing called flip is flipping back and forth, pointing to one file and not the other. So now I just run race flip. Had it there, race flip. Okay, race flip. Okay, and usually I get public or I don't have access, but every now and then, like I did right there, I will get secret. Every now and then I'll get lucky. And the secret information will be revealed because at the time when it checked, it saw the public, but at the time when it read it, it was reading the secret. So that's exploiting the vulnerable race condition. Anyway, that's what I wanted to show you. And by the way, if you do PS, you'll see that I now have a bash running in the background. And if I want to kill it, I can do FG to bring it back to the foreground, and now do Control-C to kill it. And now if I do PS, now I only have the one bash I'm using. So that's one way to stop it. Otherwise, it's going to keep running until you like reboot your machine or log off or something like that. So that's what this one works, and there's a way to get the flag here. All right. So that's what I wanted to show you.